Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. So today is the last day of the class, and today is the day that you will be able to explain what you've been doing in your assignments, and very importantly, whatever you did in the assignment will be in the final. So if you do the assignment in group and you do it properly, then you will survive your final, or else you get a problem. So that's why I limit the maximum members 5, so you will be able to have the experience doing the work. So the presentation, the mark will be done by yourself. I've given you the Google form. Okay, you mark yourself, you mark your friends based on 4 criteria that I put it there. So a very is dependent on, we call it peer review. Peer review. So please don't put any sentiment. You hate your friends, you put them very low. If I saw some group very low, I will cancel the marks. So please put your mark accordingly as per what they have achieved. Okay, the presentation will be grouped, and the best mark is if everyone able to speak. You're not going to get high mark if only one person to speak. Like I say again, you have to understand what you're doing, and the presentation will not be more than 5 minutes. And you are recorded. You will be in my YouTube channel, and I will also link to LinkedIn. So I have 27,000 viewers on my LinkedIn, so you could attract some of the viewers to contact you or to give you opportunity for internship or work. I've just copied the link of my YouTube yesterday presentation in the group, so you can watch. That is the kind of presentation that we expected. We know that we're not expecting you have been doing the job similar to what the people are doing in industry, but at least you have some knowledge how to do the actual work. So please impress, because you are you'll be recorded, you'll be on YouTube, you'll be in the LinkedIn, you also will be in the Facebook. So that's time for you to impress, to show what you've been doing. In fact, if your parents also having a link on your social media, they may also see you doing the presentations. Okay, so I will not going to call you group by group. Whoever want to do first, want to finish first, do first, and then subsequently. I think we have 16 groups, if I'm not mistaken. So we don't take too much time. Just try to explain what you've been doing and how you've been doing it, and we not really care on exactly the result, the numbers that you come up with. You must explain the methodology in coming out with the solutions, because that is most important. We're not counting numbers. We're looking at how well you explain what you've been doing and how well you've been doing it. Okay. First group may come first. You want to use your own PC or use mine? That's your choice. Okay, first group, please don't waste time. No one? This is always happening and the industry don't like this. Okay, good.
Saya
Boleh pegang mic ataupun
okay. Jangan tak saya English. Siapa intro? Betul.
Ada lah semua banyak benda. Dekat WhatsApp. Kau boleh buka.
Tak cakap lah.
Weh, cakap sini. Hello. Bismillah. Ni yang masuk dia record kan.
Yang ni nak sebelum dia cakap dia nak ikut sini.
Apa yang hamba?
Ada tas dia sini. Aku tak tahu. Legislation dia tu. Rules apa tu?
Regulation lah.
Regulation.
Chapter saya menang. Orang tak buat saya menang.
Buat. Tapi tak tahu ni sebab panjang ni.
Tak nak slide kan. Untuk kau orang tengok itu. Kau dah tahu. Betul. Mic mana? Dia record. Oh. Ni dah set up dah.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Kami daripada grup 10. So senario kita nombor 3. So first of all, saya introduce dulu my group members. Saya Zul Hakim, sebelah saya Aslam, ini Fakrul dan ini Asma. Okay, next. Okay, first of all, saya terangkan tentang isu dan senario yang ada dekat saya punya problem lah, which is failure at the fuselage skin. The factors of failure is because of depressurization, due to depressurization. Okay, next. Okay, as we know, the first thing that we do before anything is make a report damage, which in the report damage there is include about the aircraft data, inspection data about what happened to our aircraft, what happened to why the aircraft failed, and the materials that we going to use we need to include in the email that we going to send to Boeing. Okay, next. I pass to my friends.
Okay, this is the design of repair for the patch for the skin that we have removed. Okay, this is the local view and global view, and that's the location for the hole that we will cover. Okay, next. Okay, this is the dimension for the hole that we will patch up, and then this is the calculation for the load loss. Okay, as we see, there are 4 areas, and the upper and the length and the width for the A1 and for the A2 are the length times with the thickness, and for the A3 and 4 is the width times for the thickness of the skin, that is 1 millimeter. And then when we come up with the area for the A1 to the A4, we will times with the FTU and the FSU. Okay, next. Okay, this is the load design analysis. Okay, for this graph, we times FTY times with 1.5 based off the factor of safety, and then we get 405 MPa, and the result is same with the table that have been given. Okay, next. Okay, this is the calculation for our double strength for A1 and A2. We calculate for the length minus with the rivet diameter. We come up for the test, we try to make it 80 per row for the test, and then using the right hand thumb rule from 1.0 to the skin, and the doubler is 1.2 millimeter for the thickness of the doubler. And then after we calculate the area for the doubler at the A1, A2, A3 and A4, we times the FTU and the FSU. After that, we come up with the resultant force for the double strength. Then last, for the fastener, because the thickness of the skin is 1 millimeter and the material is aluminum alloy 2024, the single shear allowable rivet is 3190 Newton. And then with that number, we come up with the number of rivet per row. That is the resultant. We will divide with the number of 3190 times 3. The 3 is the number of row for the rivet. Okay, so for the A1 and A2, we come up with 80 rivet per row, and for A3 and A4, we come up with 12 rivet per row. Thank you.
Bismillah. Okay, I will continue the presentations about stress analysis. Okay, in this session we find 3 things which are the tension, shear stress check, and bearing stress check. Okay. The key point for this session is we want to find about stress, how much stress we can apply to our component or our material. Okay. For net tension, we must refer to our rivet diameter, which is 4 mm, and we take the value 3190 Newton. So we will divide with our shear area yang kita cari ya. Okay, so we find the value net tension, which is 260.6 megapascal. Shear stress check value is 195.5 megapascal, and bearing stress check 664.6 megapascal. Okay, next. Okay, for stress summary, we want to find margin of safety for each analysis. For shear out, we find the margin of safety 1.3. So the shear out margin safety 1.3 indicates that the structure or component has a reasonable safety because the value are more than 1. Okay. Furthermore, net tension also the value is more than 1, which is 1.6. So the structure component is designed with a significant safety factor against tensile failure. Okay, last but not least, bearing 1.1. Even though the value is the lowest one, but it's still more than 1, so the factor of safety is good. Okay, for next, for the graph fatigue life cycles, okay, we refer to table of thickness 405 megapascal, and we draw vertical x-axis, and we will find the value of fatigue life cycle, which is 20,000, around 20,000. Okay, next.
Okay, so I will continue the presentation, which will be the repair instruction. So the repair instruction consists 4 steps, which would be inspection, remove damage, and also the fabricate repair materials, and the last one would be installation. So basically, during the inspection, we would do a very detailed visual inspection to assess the extent of the damage. And after that, we will conduct a non-destructive testing, such as ultrasonic or eddy current inspection to detect hidden or subsurface damage. And for the second step, which would be remove damage, the first step would be to extend the damage were determined according to the guideline in the general repair section. The damaged section of the aircraft was cut off to ensure it is clean and precision cut, and all sharp edges, burrs around the cuts were removed to ensure smooth surface. The third step will be fabricate repair materials. So the most important thing when fabricating the repair materials, the repair materials must be 100% same as the materials, the original materials. So if we are using alloy 2024 aluminum, we must fabricate the same material for the doubler. So next. So for the installation, first the holes were drilled in the doubler and the remaining undamaged skin with 4 mm drill bit. And after the holes were drilled, we will allow spacing and alignment between the perimeter of the repair core and the core that need to be fixed, which gap that no more than 0.1 inches. Okay, and then after that we will install rivets to securely join the doubler, and after that we will apply sealant to provide a watertight and airtight seal. And after the doubler were installed, aligning the holes in the doubler with corresponding holes in the skin. And after that, rivets were inserted through the aligned holes and secured joined the doubler and repair skin. And last but not least, the rivets were ensured to be appropriately set and flush with the skin surface. So for the last one would be the certifications of personnel. Each personnel were assigned their own tasks. For example, Zul Hakim will carry out detailed visual inspection and design doubler, and I will do the installation of fillers and doublers, while Aslam would calculate the suitable thickness, fabricate repair materials, and last Fakrullah would do the installation of rivets and make calculations. I think that's all for my group. Thank you. A 10.
Menggigil mah. Iya. Let's go. Cabut juga. Tengok. Pusing.
شوف كده برضه
بطلع قاعد يمشي.
مشتغلش
استنى.
نبطل هذا
ما تحضر. هذه مشكلة.
لازم يبقى
لا هنا خلاص.
فيها سيكة بس
كانت يا عم نسيت والله نسيت. لا كنترول شوف start the presentation. اعملوا extend. We have to use this. شوف الوصف ايوه خلاص. Said we need to use this. No, we need to use this. Yeah, you need to use that and this. Sure. To change. أجل تبدأ أنت.
أنا أبدأ.
طيب. هدول السلام عليكم. We are group 1. Me and my group mate, we will present about design and analysis of skin repair of الطيارة.
وريني الاسم ده فين؟ ده repair design and analysis of the
Southwest Airline.
ده أنس؟
أيوة Southwest.
البتاع الصغيرة دي ركبها عندنا؟
أيوة.
أي صغيرة ركبها وخلاص. أنا اللي هكلم يا جدعان. وبعد كده كلم دوس على الجنب. ايوه الو لا ده عشان نعمل
قول الجزء بتاعك.
ها ثانية واحدة بس ثانية. سكن ريبير ابسنس 2294 ابدأ ها احنا جروب 1 صح؟ Hello, assalamu alaikum. My name is Sharqaw Ahmed Azzat. We are group 1 and today me and my group mate we are going to discuss about design and analysis of skin repair for the Southwest Airlines flight 2294. So first, Southwest Airlines flight 2294 was a planned US passengers flight on July 13, 2009 when the COVID pressures dropped, so the airplane needed to land, had to like emergency landing and at Yeager Airport no one was killed or no one had an serious injury. And a review by NTSB found that metalware caused the aircraft skin to break, which led to crash. On a skin assembly part number 65C35792, we found a hole that was about 17.4 inches long and between 11.5 and 8.6 inches around. The damage happened between body section 827 and 847, as well as between string 1 and string 2, which is 2 inches longer than string 2L. The 3 sides hole was made by 13.2 inch long lengthwise crack on the top edge and 14.75 inch long curve, roughly circumcised crack on the front edge, and another 8.5 inch long curve, roughly circumcised crack on the back edge. Material below the long edge crack and between the crack was pushed outward and flowed down and back, making a hole in the skin. So that's all for me, and let's move to friend.
So, and today I will. My name is Anas, and today I will talk about the design repair. So we will estimate like this is the skin of the aircraft, and this rectangular shape we use like the cutting, and after the cutting we will install the doubler fit. So first of all we need to determine the material specification. Next slide please. So for the material specification we will use the aluminum 20243. So and as well we will use the same material as the doubler. Next, after finding the material specification, we need to find the material allowable values. We need to determine the area for each side. We have 4 sides. So our thickness for the skin was 0.9 millimeter. So according to the manual, we need to use the doubler as 1 millimeter thickness. After finding the material allowable values, we need to find the skin area. To find the skin area, we have the length multiplied by the thickness. So we need to determine the area for 4 parts. And then we need to find the tension load loss. In order to find the tension load loss, we have this value, allowable tensile stress multiply the area. So the allowable tensile stress, we need to refer back to the table of the aluminum 2024, and we found that the FTU, it's equivalent to 400 megapascal, and according to that value, we did the calculation to find the tension load test. After this, we need to find the shear load list. Also, by referring to the same table, we can find the ultimate stress in the shear FSU multiplied by the area. After that, we need to find the resultant force, because we have 4 areas we need to multiply it by 2. So this presentation shows how we did the calculation. All the calculation was mentioned in our report. Like, we will show it to you after we finish this. So next slide, please. So after this, we need to calculate the number of rivets used. So by referring to the table, like, we decided that we will use the MS20470DD as our rivet, which is like 4 millimeter in thickness. After that, we need to find the shear allowable values and the shear allowable. Like, the shear allowable will be single shear allowable multiplied by number of the rivet. To find the shear allowable, we need to go to the specification of the rivet, and our shear allowable value for each rivet was 3190 Newton. And multiplied by the number of row, we determine that number of row, each number of rivets per row equivalent to 3. So after that, we need to find the number of rows and then the rivet spacing. So after that, we need to stick the rivet on the doubler. So we need to find the doubler strength. So next slide, please. So in order to find the doubler strength, we need to follow this rule and find the material allowable value. So, and like, find the skin, find the area for the doubler, which is the length multiplied by the thickness. We need to find the tension load loss, the shear load loss, and the resultant, same as the skin. After we find the doubler strength and the load loss, we need to calculate the margin of safety. So next slide, please. So the margin of safety equivalent to the doubler strength over the load loss. Our first calculation, we found out like if we use the same material as the skin, the margin of safety will be equivalent to 0.845, which is less, or it's like the load cannot be transferred through the doubler and it's not safety. So that's why we need to make another calculation by using a different material, which is AISI. And we did the same, when we do the same calculation for the stainless steel AISI, we found the margin of safety equivalent to 1.54, which is safe to flight according to the manual. So that's all for my part. I would like to pass my colleague to explain more about this part.
My name is Hamza, and I'll be talking about the stress analysis. In order to find the stress analysis, we have to find the net tension, shear out stress, and the bearing stress. In here, there are the formulas which we need to find each of these. The bearing stress, we'll start with the bearing stress. The bearing stress measures if the rivets will be able to withstand the stress on the rivets due to the loads on the aircraft. When it comes to shear out stress, we check whether the edge distance, which we included as 2D, is good enough to withstand the stresses. And when it comes to net tension stress, we ensure that all the rivets are able to carry the load equivalently without any too much deformation or anything. Next slide, please. Here are the values that we got from our stress analysis, and as you can see, the shear out and net tension stress are in reasonable margins of safety. However, the net tension stress is a bit lower than the recommended industry amount. And when it comes to bearing stress, it's only 1.09, which is not suitable, as any abnormal loads on the rivets would allow the rivets to shear. So we believe that we do not comply, the factor of safety is not complied in the bearing stress nor the net tension stress. Next slide. I'll pass on to my friend for this part.
Assalamu alaikum, my name is Syed Muhammad Usama. In this part, we need to determine the possible lifetime or the fatigue life. We have this graph that shows the relation between stress and the fatigue life. First, the maximum stress will be 400 megapascal, determined by the table of material that we used. From the graph shown, it is determined that fatigue life cycle is 50,000. And thank you, and I will move to my friend.
Assalamu alaikum. Now we have an inspection of damage area. First of all, visual inspection. Initially, we check the area around the damaged areas for any signs of corrosion, cracks, deformation, or any other types of damage. Second, marking defects. If any notable defects were found, we mark the area. NDT inspection. Once the part is removed, we send the part for high magnification optical viewing to gain a better scope of a damage caused to the area and its vicinity. Fourth, measuring damage scope. The damaged part is measured and a sketch is made to determine the size of the cut on the damaged area. Next. Removing damaged part area. Cleaning damaged area. Before we start conducting the removal of the damaged area, we clean the area around the damaged area of dust or any other kind of contaminants. Determine cut type. We opted to go for a rectangular cut of 24 times 14 on the damaged area. Marking the cut area. Designated area was marked, so the damaged area is in the center of our designated area using marker. Removing the rivets, we remove all the rivets in this area using a drill. Cutting the damaged area, we use jigsaw to cut out the damaged area. Smoothening the cut, sandpaper and files used to smoothen out cut. Next, fabrication repair material. Cutting the doubler. For our proposals, we cut a piece of stainless steel AISI 301 using a metal cutter machine. Smoothening the cut, after which we sanded the edges with the help of abrasive paper and files to smoothen the cut area to make it easier to maneuver when it comes in installation. Next, installation of repair. Drilling rivet holes. Once the rivet were decided, we started to drill holes on the skin and the repair area. Protective layer. Before we bring out the doubler, we have to anodize and apply sealant on the doubler to minimize any chances of corrosion. Riveting the patch repair. With the help of a rivet gun, a bucking bar and a colleague, as the structure is not accessible on both sides. You require help from inside the aircraft. I will pass to my friend. Continue.
Hello everyone, I'm Muhammad Tad. Skip. Next. Okay. Alright. Alright, thank you everyone. That's our presentation to show how the process for our work.
For more information, refer to the report. More information, refer to the
No report. أحلى هنا يا عم، خليه يا عم بدي ولا هنا. أحلى الشغل اللي فات. كده آخر واحد. أيوه أنا بعد كده.
Did we do? Oh shit.
Pakai mana? Ada tu tak?
Ada.
Tak minta dia orang punya.
Tak ada adapter. Dia tadi dia MacBook. Dia taxi.
Mana ada adapter pun dia ni?
Ada adapter.
Tak ada adapter. Sekejap. Tanya tak ada. Sekejap. Dia ada tanya saya.
Duduk dulu. Bayar masa.
Aku takut apa aku cakap yang ni dengan masih masuk video.
Masuk. Ada sini transfer data. Nak transfer kat Sir? Transfer kat Tun. Transfer. Tun kawan. Oh boy. Sekejap, saya pun ni. Pakai laptop kita transfer.
Nak bagi sana?
Nak pendrive Sir?
Sir.
Saya ada adapter tak?
Oh, ni HDMI ni. HDMI dia belakang.
Belakang
Grup 9 je. Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Simabaiki Shrabi Israel, and then and today we are going to be to present our case study about the flight of Southwest Airline, and the aircraft that we will be discussing is the 737-300 Boeing. Okay, and as you can see on the photo attached above on the slide, this incident took place in 2011, where the aircraft experienced a rapid depressurization, in which it tears off all the top crown aircraft skin,
and reveals the stringers and body station. So as you can see on the damage profile, the 60-inch damage was a tear up of the aircraft screen inside out, and a damage repair need to be made in order to restore the aircraft on its original condition. Okay, I will pass to Sakawi for the next.
My name is Mohammed Sakawi. So the next step, we're going to do a aircraft report or damage report, as you can see on the right side. And on the left side, this is the report that's going to be made. Okay, next we're going to do a recommendation letter that's going to be passed to the Boeing aircraft, which is the manufacturer of the aircraft. The function of the letter is to ensure that we got their recommendation and verification on the repair design that's going to be made later. Okay, so next step, on the left hand side, we can see the drawing. So the drawing is actually the cutout of the defect of the aircraft component material skin. So the solid line is actually the design which we made to provide a neater and a greater dimension for the design letter. So as you can see, we carve into a rectangular shape. So we just can assume that the area on the A1 and A3 is the same, and A2 and A4 is the same. So after that, we're going to need to find the cross-sectional area to be using into the next formula, which is the stress over force over area, to find the load carrying capacity loss. So on the right side, we can see that is the stress strain curve. This is the function to find the material stress before it going into plastic deformation, and the value is a 405 megapascal, which can be seen from the table. I'm going to pass my presentation to Ahmad Safwan.
Okay, next we need to find load carrying capacity loss. The reason we need to find load carrying capacity loss is we need to know the doubler. We need to know how much load the doubler we need to make at that part. So the formula is F equal to MA. So we substitute, first we need to find tension. We substitute tension 405 times by 4.2 10 to the power of -4. Then we find the shear, and then we find the resultant for the area A1 and A2. After that, we do the same at the area A3 and A4. So from this load carrying capacity loss, we can make a doubler.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Shamin Asrawi. Okay, so for the next assignment is basically we need to find whether the doubler that we are going to use will restore the load loss. So in order to achieve this, we must first find the load loss, find the doubler strength, and find the factor of safety. And the factor of safety according to the manual for the aircraft is 1.5. Okay, first we find the load loss just like the previous assignment. However, we take into account the rivet area, because the maximum stress occur to the least area. So this is the area where, as you can see at the left side, that is the cutout of the skin, which is the least area. So then we determine the resultant force of the load carrying capacity loss, and then we use the doubler the W thickness should be 1 gauge higher. However, if you use the 1 gauge higher, we couldn't achieve the 1.5 factor of safety. Therefore, we use 2.2 millimeter of thickness of W. And then, next. And then balik. And then we find the W strength, which is on the right side. Okay, next. After that, we find the margin of safety. So, formula for margin of safety and factor of safety is the W strength divided with the load loss. So that we get 1.5, which is for the margin of safety. We need to find it higher than 1, and for factor of safety, we need to find higher than 1.5. So, factor of safety, the function of to have 1.5 factor of safety is to have 50% of extra load that the W can carry to cover other errors such as the vibration. Okay, so next we find how much rivets that we need to use to attach the W to the skin. So the formula is the original load loss over the force by the rivet. So by the rule of thumb, 1 row we must use 3 rivets. So for the single rivet, it can withstand 2,680 Newton. Therefore times it by 3 and we get 8040 Newton. And then we get for area 1 and area 2, we need 19 rows of rivets, and area 2 and area 4, we need 101 rows of rivets. Okay, next. Before. Siapa nak ambil gambar? Okay. Okay, so stress analysis is to analyze whether the rivets, how much force is needed to this kind of damage to occur. So there are three stress, which is net section tension, shear out, and bearing. So for the net section tension, we get 169.83 megapascal. For shear out, we get 76.14 megapascal, and for bearing, we get 304.6 megapascal. Next. Okay, I'll pass to the next presenter.
Okay, so for the next assignment is for the components of. Okay, so we want to see if the design comply with all the regulations and stated as per stated in the assignment. So there will be 2 subparts we will be discussed. First one is subpart C and subpart D. For subpart C, there are 5 items. Okay, the first one is factor of safety. The second one is loads, strength and deformation, proof of structure, and damage tolerance and fatigue evaluation of the structure. So for the first one, talking about factor of safety, as Shahmi explained earlier, factor of safety, initially we use the doubler that 1 gauge higher, but it yields a factor of safety lower than 1.5, which does not comply with the subpart. So in order to comply with the subpart of a factor of safety, a higher gauge of doubler has been used, which is 2.2 mm. So moving on to the next subpart, which is loads. Loads, based on the subparts that have been stated in the regulation, the one thing that I want to stress out is the strength requirement specified in terms of limit loads and the maximum loads to be expected in service and ultimate loads multiplied by prescribed factors of safety, unless otherwise provided. Prescribed loads are limit loads, and this could be seen in the assignment 4. Okay. For the next subpart is strength and deformation, which stresses the structure must be able to support limit loads without detrimental permanent deformation. And any load up to limit loads, the deformation may not interfere with safe operation. Which in this case, the design structure, the design repair must be made to withstand all the limit loads that have been stated in the stress analysis summary. Okay. The next item is the proof of structure, which stresses the compliance of the repair design with the strength and deformation requirements of the subpart, and it must be shown for each critical loading condition, and this can be seen also in the stress analysis in assignment 5. Okay, and for the last one, which is the damage tolerance and fatigue evaluation of the structure, it stresses out the evaluation of the strength and the detail of the design, and fabrication must show that catastrophic failure due to fatigue, corrosion or manufacturing defects will be avoided throughout the operational life of the airplane, and this can be seen on the assignment 7, which is the next assignment, or the life of repair, the one that we measure the fatigue cycle of the repair. Okay, I will pass to Sakawi for the next subpart.
So next for the subpart D. So the first subpart is going to be the material strength and properties with the material design value. This can be found to refer to the assignment 4, which are the double strength, which we find to ensure that the double strength can restore the load that is lost. Next, the fabrication method. This can be seen in the assignment 9 letter, and the fastener 4, and for the fastener we can see in the assignment 4, which is in the report at the fastener 4, assignment 4 fastener. As you can see on the right side, there is we can find the number of the fastener that we can be used later. And then the next is the material. Material, we can refer to the item number 4 in the report, which is state that the material of the skin is the aluminium alloy 2207. Aluminium alloy 2207. 2024. Yeah. And last is the proof of strength, which can be found in the stress analysis that has been searched by Shahmi in the report. Next, I'll pass to Ahmad Arman.
Go. Next slide. Okay, as we can see this graph, our maximum stress is 505 megapascal. So we found that our fatigue life cycle is 8,000 cycle. This indicates that the material can endure a repetitive stress that ranging from the minimum to the highest, which is 505 megapascal. Approximately, it can undergo 80,000 cycle more until its failure. Next slide. So this stress summary indicates that our skin can withstand the stress or not. So the first we find out shear out. So as we calculate all the shear out stress, we get that 3.35, and it's above 1. So our skin can withstand the shear out. So the second one, we found that is net tension. So as we calculate, it found that 2.38, and it's more than 1. So it can withstand the tension failure. And the last one is bearing stress. We calculate that, we found that the bearing stress is 1.66. That is more than 1. So it can withstand the bearing failure. I think that's all for me. I pass it to
Okay, for assignment 9, for assignment 9, we need to repair the damage. Here there are 4 steps to repair the damage. First, inspection. Okay, for the inspection, we need to carry out the detailed visual inspection. The reason is we need to find any crack or dent at the damage, and then if we find any crack, we need to proceed to the NDT test to find a proper hidden damage. Okay, second step is we need to remove the damage. First, we need to cut off the damaged section using a proper cutting tool such as grinder or saw, and then we need to remove sharp edges, and lastly we need to clean all the debris around the damage. For the third step is to fabricate repairs material. First of all, to do this step, we need to find appropriate materials in the maintenance manual, and then determine the size, shape and material requirement for the doubler. Fabricate the doubler according to the size, and then cut or sharp the doubler materials and smooth the edge. And last step is installation. First, we need to drill holes according to its size, install rivet, apply sealant on the doubler and install the doubler. Okay, that's all for assignment 9, and that's all from us, group 9. Yeah. Okay, thank you.
Ni apa ni?
Ni mic tu.
Oh, siapa bangsa ni? Oh, mic ni lah. Record.
Ni mic. Mic hall.
Ni mic record. Oh shit man. Tutup sir. 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 Aku dah agak dah.
Tak apalah. Dia datang muji dia.
Pinjam dulu. So kita letak.
Ini senang ni.
Ni magang Fred. Oh tahu tak, aku dah cakap dah, kau SV aku dah hantar gambar. Tu kat atas ni. Laju buat begitu. Kau relax lagi sebelum nak tanya orang, buat tahu. Boleh tak? Oh sini boleh.
Tak nak yang latest punya ni kat bawah. Ni dalam duduk. Tak tengok yang kat ni Google Drive.
Sit. Dah, siapa nak jaga? Kau lah last, kau lah jaga. Ayo. Yes. Ustaz.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good afternoon to all of you. So we from group 7. Actually our group consists of 5 members, but unfortunately one of our friend is on medical leave. but never mind, we still proceed with the presentation. So today we have me, myself, this is Daniel Adam bin Azami as the leader from group 7. Then we have Aiman Zikri, Muhammad Ilyas and Aizudin Akifitri. Okay, proceed with the next slide. Oh, sorry. Okay, now we are on introduction slide, which is the first slide. So the chosen problem for our group is, and for our assignment is on the Southwest Airlines 2294. So the scenario started when this aircraft, which is the 2294 Southwest Airlines, is actually a scheduled passenger aircraft where they experience rapid depressurization on the passenger cabin. The aircraft then made an emergency landing at the Yeager Airport, which is in the Charleston, West Virginia. And according to the NTSB, which is the National Transportation Safety Board, the probable cause for this accident was the fuselage skin due to metal fatigue. So that is the introduction for this assignment. Proceed with the next slide. Hi, Muhammad. As you can see on this screen right now, we're going to show you the description of the damage for the scenario that I presented just now. On the left image, we provided a fully aircraft which we specifically put the damage, but I think you guys cannot see it, right? But the thing that we noted there is a hole on part of the fuselage skin of this aircraft, which is its dimension is about 17 to 8 inches, and it was discovered on the body station BS 831 and 844. On the right side, we have provided the local view for the damaged part of the accident. So you guys follow, right? To be more detailed, we have provided the third slide, which is on the NTSB report, which they said the probable cause of the accident was due to the fuselage skin failure due to the pre-existing metal fatigue, which includes the plates or skin on the auxiliary fuselage. Some of the signs that they found on the aircraft is, we can say there is a fatigue, wear, corrosion sign, and some of the damage that we found, there is a three-sided hole of the aircraft, as I just presented in the second slide just now, where its dimension is approximately about 17.4 inches times 8 9, that have made a big impact and caused the accident for the Southwest Airlines 2294. So that's all for the introduction part, where we have done describe the aircraft accident causes. Now I will proceed the presentation by passing this mic to next presenter, which is Muhammad Ilyas, where he gonna describing our design of repair for this aircraft. Thank you.
Yeah.
Oh shit.
Boleh dengar sini. Alright, Bismillahirrahmanirrahim. Assalamualaikum and a very good evening to everyone. So, on the left side of the PowerPoint slide is the damage of the aircraft, where the hidden line represents the damage and the solid line represents the cut that we have made for the repair. The dimension of the damage is 11.5 inches and 17.4 inches, and our repair is bigger than that, which is 15.5 inches and 21.4 inches. So on the middle part of the slide is we want to find the load carrying capacity that is lost. And from table 2 of A320 SRM ETA 51-70-11, we get the stress
and tensile, which is 405 MPa and 255 MPa. And based on those numbers, we want to find the tension, shear and resultant, whereby the resultant is the amount of load carrying capacity that is lost. To be able to get the resultant, we have to combine the tension and shear, where it is the square root of tension squared times shear squared. And that is for A1 and A3. The next step is to repeat the same process for A2 and A4. Now on the right side is the load design analysis graph, where from the graph we can determine that 270 megapascal is the amount that can be used. Okay, next slide. Now moving on to repair design analysis, where the first step is we convert inches to millimeter and from millimeter to meter. The formula for double strength is stress times area. So we find the tension and shear, combine those two to get the resultant. Now the margin of safety for our aircraft, the formula is double strength divided by load loss must be more than 1. So by following the standard practice of 3 times 3,660, we get the amount of rivets. Now for number of fastener is 300.93 kilonewton divided by 10,980 newton. So we get 28. Now for A2 and A4 is 416.56 kilonewton divided by 10,980 newton. So we get 37. To determine the amount of rivets required is those two answer times that by 3. So for example, A1 and A3 is 28 times 3. So we get 84 rivets. And for A2 and A4 is 37 times 3. So we get 111 rivets. Now I pass the mic to Ivan Zikri for the next slide.
Okay, Bismillahirrahmanirrahim. Assalamualaikum and good evening. So my name is Muhammad Ahmed Zikri. So I will be explaining about the stress check, or we call it as a stress analysis. So essentially there are three primary stress that we want to check, which is the net tension stress, the shed out stress, and also the bearing stress. Okay, so the formula for net tension stress is the resultant force over divided by the area, and then for the shear stress over the rivet CSA, and also the last one is the bearing stress is resultant force on each rivet divided by the rivet CSA. So as you can see on the screen in front of you, so the net section stress or tension is for our group is 7.728 megapascal, and for the shear out is the stress would be 76.25 megapascal, and the bearing stress would be 305 megapascal. So yeah, next, after we get this calculation, the value, we can calculate the margin of safety. So the margin of safety is essentially the ultimate stress divided by the amount of stress that we got from the earlier calculation. So which in our case, for the shear out stress, the major margin of safety is essentially more than 3.34, and for the net tension is 52.41, and
the last one, the bearing stress will be 1.66, which is and we found out that all three of them are able to withstand the shear up, the tension failure, and also the bearing failure. So yeah, I will pass the floor to Muhammad Aizudaki Fitri. Thank you.
Hi, Assalamualaikum everyone. My name is Akif. So I'm gonna talk about life of repair. So basically on the graph, you can see the remote stress range versus the fatigue life cycle. So this illustration illustrates the stress on the aircraft and the fatigue life cycle. And in this graph, it also presents the data of the stress from the certain part of the aircraft, which is life of aircraft and life of repair is focused on stress range threshold of component that can undergo repair and maintenance to extend its own fatigue life. So by analyzing this graph, the person can determine the critical stress of the certain part, which it can maximize the operational lifespan of the aircraft. So as you can see from the graph, so the maximum stress of the part is 416 megapascal, and the effective life cycle is 1500,000 cycles. Okay, so this is about life of repair. Moving on to the next slide. So we have 4 main points which consists of repair instruction. So the first thing is inspection, which is the first one is carried out with visual inspection, and the second one is the NDT, if the damage is found. So talking about the visual inspection, as a personnel we have to examine the damage area and looking for all the cracks or fractures or any signs of damage, and we have to make a documentation about the visual inspection. And for the NDT, we have to use appropriate NDT method, which we did on the last 2 steps on how to do the NDT. And then moving on to the next point is remove the damage. So first of all, we have to cut off the damaged portion. So the first thing first, we have to use the correct tools to cut the tool and make sure the cut is clean. And then after cut the damaged portion, we have to clean all the sharp edge by using files or sandpaper to smoothen the edges. Next. Alright, on the third point, fabricate repair materials. So on the fabricate repair materials, we have 2 steps, which is first of all, we have to prepare the fiberglass filler material, which we have to follow the steps provided by the manufacturer and using appropriate protection like gloves or goggles when handling the filler material. And for the part of fabricate the doubler, we have to determine the size and shape in the material for the doubler based on the structural design and repair specifications. And the last one is about installation. So installation, we have 4 parts: drill holes of the appropriate size, install rivet or the fastener, apply cylinder on the doubler, and install the doubler. So I think that's all from us. So that's all from Group 7. Thank you.
Alright, thank you. Good. That's very good. Good. Good, sir.
Hah?
Tu.
Oh,
sampai boleh.
Sorry. Aku
Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good evening. So our group represents about the repair of aircraft structure, which is Southwest Airlines Flight 812. So this is all my group member. Next. So first step we need to do is with sketch, which is a global view and a top view. So next. So the next one, we do our sketch, which is to detect the defect, which they have upper skin and also the lower skin side. Cool.
Okay, Assalamualaikum. My name is Muhammad Afizudin. I would like to talk about chapter 2, which is the aircraft defect and damage report. Okay, so the data is the Boeing 777-300 was operated by Southwest Airlines flight 812, where the fuselage skin was damaged in April 1st, 2011 during in-flight from Police Skies Airport International Airport to Scarborough International Airport and need to be repaired. Finally, the aircraft was returned to service on 3rd April 2011. Next. Okay, so about the data is the marking on the screen panels by the surrounding the crown screen panels BS540 to BS727. So about the detail of finding defect, the schedule is accurate, which is the visual. So the detailed defects and the mesh was the adjustment of fuselage. The length is 60 inch, width 8 inch, and depth not applicable to the direction is left hand side, and the location is outside. So the result is the rapid depreciation. Next. Okay, for the type of material is affected by the El Nino, which is unusual event is none, and for the detailed existing adjusters repairs by the National Transportation Safety Board, determined that the cause of the accident was the improper insertion of the fuselage crown skin panel, and which results in multiple side fatigue cracking and eventually failure of the lower skin panel. So that's the point.
Okay. So the next step. So the next step is we sketch our repair design. First off, we done our sketch, and then the second one we find our what we call it, the stress, which is 405 megapascal and 255 megapascal, and then we done our calculation, which is area for the shear and also for the tension. And the next we done and we got our resultants on the bottom bar. And the next step we got a 405 megapascal for this calculation. So next. So the next step is we done our calculate load loss, which is we got a 7 times 10 power 3 for area 2 and 440.54 times 10 power of negative 3 for the area 1. And for the total double strength we got is 10.34, and the next step is margin of safety. So for the margin of safety, we need to calculate this by double strength divided by load loss. So we got is 4.78 times 10 power of 54. The next is a factor of safety, which is we need to find this one is by using the ultimate strength over design strength. So we got is 4.785 times 10 power of 4. And then we got our method for calculate and select for the we call it derivative from this table. So next. So after we complete all that one, we do our we find out each of which is neck tension, bearing failure, and shear out stress. So next I will pass to Azani.
Okay, Bismillahirrahmanirrahim. My name is Muhammad Azani, and next I'm going to cover chapter 6. So for chapter 6, we'll be discussing airworthiness design requirement for the large transport aircraft. And this design requirement must be satisfied either through test, inspection, and design review. So in this chapter, we'll be focusing on 3 subparts, which is subpart C, D, and G. So let's start with subpart C. So for the first subpart C is the factor of safety, and requirements must be meet 1.5. So for the second is strength and deformation. The requirement is that it must be able to support limit loads without permanent damage. And for the third requirement is the design airspeeds, which is that it must be a minimum value of VC, the minimum value of VC must be greater than VB. So for the fourth is the high lift device, and the requirement is that it must be able to establish stages during flight with the wings flat and the corresponding stages. So for the last one, the fifth is the pressurized compartment loads, and it must be strong enough to withstand the flight loads. So move on to the subpart D. Subpart D. Okay, now we're going to talk about subpart D, and this section will also cover 5 requirements. So for the first requirement is the protection of structure, and that it must be protected against external deterioration. So for the second requirement is the special factor, and the original factor of safety must be multiplied by the highest pertinent special factor of safety. So for the third requirement is the fictive factor, and that it must have a fictive factor of 1.15. For the fourth is joints, and it must have a factor of safety not less than 3.3, and but it can be lower to 2.0 depending on the joints. And for the last one, the fifth is the hulls. It must have a watertight compartment. And next is the subpart G. For this one, we only have one requirement, and which is the which is the maximum operating limit speed. So it is a speed that may not be deliberately exceed in any regiment flight unless authorized. Next, I will be passed on to my next colleague.
Okay, next. Okay, for the next is this is based on the maximum stress of repair and roughness estimate possible life based on stress. So this one we got from our calculation first, and then next. So for this one is a conclusion from the chapter 5, which is for the stress shear out, which is we got the margin of safety is 4.0 for the 405 megapascal and 255 megapascal for the 2.9 margin of safety. And for the net tension, we got is 405 megapascal, and then the margin of safety is 1.4. And then for the bearing is 405 megapascal, we got the margin of safety is 1.8, and the value of 255 megapascal for the margin of safety we got is 1.1. So now we pass to my colleague.
Okay, Assalamualaikum and very good evening to everyone. Okay, for this chapter is about procedure on how to repair the damage on the aircraft. First of all is inspection. There's two types of steps, which is carry out the detailed visual inspection. We must first of all we must identify the material we use, and we must fully clean the damaged area. And if damage found, we must contact NDT also to find the hidden damage. Next is to remove damage. First of all, we need to cut off the damage with suitable tools such as apa dah nak cut ni? Nak cut benda ni apa? Suitable tools, and then we need to clean all the sharp edges from the damaged area. Next is fabricate repair material. We need to fabricate filler, and then we need to fabricate doubler. This all according to the calculation that we
done, and according to maintenance manual. The last one is the installation. Do installation. We need to We need to drill holes according to appropriate size. Install rivet according to the calculation that we done, and then apply sealant on the doubler. And last but not least, we need to install the doubler. Also same according to the calculation that we made and maintenance manual.
Okay, that's all for you.
Cuba mana tu?
HDMI mana mouse?
Next presenter siapa? Southwest. Sana sebut Southwest.
Awak kau kena comel lah. Awak kau comel. No, nampak terang.
Dah. Okay. Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafiq and I am from Group 6. Today we will present about our investigation about Southwest Airline Flight 812. Alright. From the history, about April 1, 2011, that this flight, Boeing 737-300, was suffered from the depressurization, cruising at 34,000 feet. And this incident happened at the Yuma, Arizona. Alright. From the investigation, that they have a hole around 60 inch at the upper of the fuselage. Okay, next. Alright. For the what?
Ni dah terang belum? Global view dengan local view. Dah.
Alright. From the damage report is we'll find that have a section of fuselage skin about 6 inch long by 8 inch wide had fractured and flap open on the upper left side above the wing. Next. Oh, dah terus ke situ terus. Alright.
Macam nak klik kata dua. Klik. Kan mic.
Okay, next is design of repair. For our case, the damage dimension is 60 inch in length and 8 inch in width. So the first step, we calculate the area. Okay, so the first area we calculate the front view which is the length, and the second one is the width, which is the 8 inch, and then we get the area. The first area is 2192 times 10 power of negative 3 milli square, and the second one is 1.6256 times 10 power of negative 4 milli square. And then the second one, we calculate the force. We use the formula which is stress times area, which is the area we calculate from the first step. And then the stress we derive, we refer to the table in the maintenance manual, which is based on the thickness of the skin. For our case, the thickness of the skin is 0.8 inch, and then therefore the FTU is 405 megapascal, and FSU is 285 megapascal. And then we calculate the resultant force. For the area 1, we got 70. For the area 1, we got the 77.8 kilonewton, and the second one we got the 583.5 kilonewton. Okay, for the graph is deformation graph, where we can know the maximum load that the skin can withstand. Okay, next I will pass to Farah. Sorry, I will pass to Wafiq.
So for the assignment 4, which is repair design analysis. So due to there is some maybe wrong calculation, I just explain about the step that we do. So firstly, we calculate the double strength. Double strength is quite same with the first with the load loss that we calculate, but the difference is we use one thickness higher than the skin thickness. So and then we calculate the number of rivet, which is by the rule of thumb. One row we need to have 3 rivet. So the force of the rivet will be times with 3, and then the resultant force of the load loss will be divided with the fastness strength. Yeah. And then we calculate the margin of safety and for shear and tension strength. Okay, for the thickness of the doubler, okay, that one is 1 gauge higher. Next slide. Sorry. Okay, for assignment 5, we calculate the tensile force, shear force, bearing stress, and fastener shear. So here we calculate, first we calculate area of the for tensile we calculate the area of the section. Okay, and then for shear we calculate the shear area, where we need to plus with 2 times with diameter. And then for bearing stress we calculate the bearing area, and then fastener shear we calculate the cross sectional of the rivet. Rivet area, yes. So for the next, I will pass to another presenter.
Okay. Assalamualaikum warahmatullahi wabarakatuh and good evening to everyone. Okay, now I will explain for assignment 7, which is life of repair. As you can see here, we take the fastener shear stress from the previous calculation, and by referring to the graph shown here, we can find that the value of estimated fatigue life cycle is around 120,000 cycle. And next slide please. Okay, thank you. And for the stress summary, we take the result from the stress analysis of the shear stress, tensile and also the bearing stress. Then we can find the margin of safety for each stress by dividing the, what is it called?
Force divided by area.
By dividing the force divided by the area, and then only then we can remark whether the skin can withstand the stress or not. Okay. I will pass to the next presenter, Haziq. Dah. Aku dah habis. Sekejap, sabar. Dah.
Betul.
Okay, Assalamualaikum and very good evening. My name is Daniel Haziq. So, I will explain to you guys for assignment 9, which is repair instruction. So, for this issue, we need to go to 4 processes. Which is the first one is inspection. Second one is removing the damage. Third, fabricating the repair materials. And the last one is installation. So, basically, this is all the procedures that we need to go through. So, for inspection, we need to conduct visual check of the area of the aircraft. So inspect any of the crack or dents and any other signs of damage on the aircraft part. Next, we need to examine the structure. Also need to find any sign of fracture and dents. And if any damage is discovered, we need to conduct a non-destructive test, which is called NDT test. Okay, for second process, removing damage, the first one we need to using appropriate cutting instrument such as grinder or saw to remove the damaged section. Then we need to remove all the pointed edge to make sure the safety. So to remove the pointed edge, also you need to using any file or grinder. And the last one is removing all the debris, contaminants and unsecured materials from the repair area. Okay, for fabricating repair materials, firstly we need to prepare all the filler materials and then using proper protective equipment to protect ourselves, and then properly blend the components, use reinforcement patch or plate, and we need to determine the size and shape of the patch and plate, and then trimming the double materials, and lastly is setting the edge and surface. Okay, last one is installation. First we need to drill holes, and we need to use the drill bit that matches the diameter. If the hole is 4 mm, and then we need to use the drill bit with 4 mm. And position the drill correctly to create holes in the structure doublet. Second one is installing the reverse or fastener. So all the basic techniques. The third one, apply sealant on the doubler, and the last one is installing the doubler. Okay. Okay, so that's all from us. Thank you so much.
Berapa ni?
6.
Okay. Reminder. You are presenting to the maintenance manager. And the certain time. So, you should do presentation. You don't read all the numbers. Okay? You are just next time you will be doing presentation, right?
Last next year.
We going into that. Anyway, you cannot afford that's fine. And then you're going to work. So please be your maturity here. Then first looking at the corner flocking there, it's not a nice thing to do. And be mature. Don't just smiling, but just take this very, not for you, I'm talking for everyone. Please treat this as a rehearsal training for you at work. So just imagine sitting here or sitting behind listening at the maintenance position. Okay, you have to feel that confidence, you have to feel that seriousness, you have to take this very seriously. If you are trying to look at the slide, you try to read numbers, we managers don't like that. What we want, you need to tell us what is the problem, how you want to fix the problem. So it means that you explain the problem, I don't know how I'm a maintenance manager. I don't know the details, so just explain a bit on the problem, then what you do, you read the information, you read the report, you write a memo, you revise. That's your action after you see the problem. And secondly, you show your concept repair. How you going to fix it? You show the slide where you have some concept repair. Then you explain how you do the analysis. So that's the approach. Maybe you're not prepared for it. I do not want to penalize on that, but again, please stick to that. First, so we took our time taken here, reading the numbers, reading the slide. Just explain. Just show one step, explain briefly what are on the slide. Okay? How many more groups to finish?
Right.
So we try to. What's your time to finish? 5:30.
Yeah, 5:30.
We'll try our best to fix it, otherwise we'll try to fix how to finish it. So please bear in mind this is training for you. Okay? Try your best. You do not get this much presenting your things, your ideas, what you do. This is your rehearsal, your training. Please do that. Okay?
Siapa? Kali ya?
Cabut yang ni juga.
Ni korang juga ke? Pinjam?
Kau buat ni ke? Kau tahu?
Sama sana.
Sampai?
Pinjam dia.
Pasal ni.
Oh, sini kan? Sampai?
Debu.
Explain lagi tu. Bukan kan? Banyak.
Yeah, Assalamualaikum warahmatullahi wabarakatuh. So, me and my team is from Group 16. My name is Muhammad Bacha. We are doing design report for Boeing 737-300 in repair. So, next slide, please. So, okay, brief explanation about the aircraft. So this aircraft is from Southwest Airlines flight 812. So the skin has structural failure at the fuselage skin at the top of the aircraft because of the rapid depressurization. So the hole approximately is 60 inches long and 8 inches wide on the upper fuselage. Next. So what we do next is we doing the damage report on the damage. So in this report we put the aircraft data, the component data, and how we find the damage. Next. And then the detail of the damage, about how big is the damage, the size of the damage, and the cost of the damage. Next. And then we provide the letter to the Boeing for the approval of the repair recommendations. So next. Okay, next I will pass to my other team members. Yeah.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, my respectful lecturers, my fellow industry, and my fellow students. Okay, after we've done a few reports on our aircraft, so we proceed with on our report analysis on how it looks like. So this is the design of our repair. So you can see here all the dimensions and all the areas. Okay, proceed to the next slide. Okay, then we have analyzed everything. This is a rough of calculation that we're going to make to put in our report. So this is the resultant and anything is related to the material. And the analysis that we're going to put in our report is the image slide here. Is the basic about the double strength, the margin of safety, the load loss, the shear, anything all. And next is going to be about the stress analysis. Okay, the stress analysis is about the net tension, shear out, bearing that is going to at least the manufacturer going to know roughly the idea of what our team wants from them. Okay, that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh, and very good evening. So next is about stress summary. So the net tension that we get is 107.1, which is the margin safety is 1.3. So it is sorry, the net tension is 263.9, the margin safety is 1.5. So the margin safety is above the recommendation, which is 1. Next is shear out is 0.97, 0.91, which is margin safety 1.3, and also above that reasonable safety margin against the shear failure. And next is bearing is 791.67, which is margin safety is 1.1. Next. Okay, so the length of repair from the maximum stress range that we got is 0.5, and the fatigue life is estimated like 50,000 cycles. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I will present about inspection. The inspection have 4 steps. Okay, the first inspection is carry out a detailed visual to find a crack or other sign of damage. The second step is to do NDT testing to choose appropriate NDT method based on the material of structure. Then we have remove damage. Remove damage is cut off the damaged portion using appropriate cutting tool to ensure the clean and smooth to facilitate proper bonding of the repair material. Then we clean the all sharp edge resulting from the removal process. Finally, to get a smooth edge using a file, sandpaper or any deburring tool. Next, the fabricated repair material fabricated a filler material that matches composite structure properties of the original materials. Then we follow the instructing the provide for mixing for the filler material. Then when we create a double material that will be installed over the repair area, we determine the size, shape and material required, cut and shape the doubler using a appropriate cutting tool, then smoothing the edge of surface of the doubler. The step of installation is make a hole using a drill with the size mesh with the Tuzen fastener. Position the drill accurately to create hole on the doubler and structure. Then install the rivet and fastener using the appropriate riveting or fastening technique. Then follow the manufacturer guideline or AAM to determine the required installation top of force. After that, using the suitable sealant, using a brush or spatula, then install the doubler. Position the doubler aligned with existing structure. Then press the doubler firmly into the surface, and then verify the doubler is properly aligned and secure.
Okay, I think that is all from us. So this is our and the end of our report. So I hope we are from Rule 16. Rule 16. Okay.
Ni siapa ni? Saya punya.
Siapa dia sampai lu?
Ni tak apa.
Template.
Mata dulu. Mata dulu kan? Okey.
Siapa nak buat flight?
Di mana masalah ada?
Siap-siap.
Nggak tahu. Dia ada recording. Patut dulu. Patut. Dekat-dekat.
Alright. Assalamualaikum and good evening to all, to sir and to all. Okay, so I'm Fatul Iman from Group A. Okay, now. Okay, next slide. Okay, so for assignment 1, we do for aircraft 737-400. So this is for global view. And the other global view, yes, this one is the damage found on the left wing side. Yes. So yeah, this one, this one is local view of the damage. Okay. Okay, so this one is the detailed dimensioning of the damage. So yeah, around 20 diameter. Of the holes. So yeah, that's the damage that we found on the left side of the wing. Alright, so next is damage report. So in damage report, we include all the information that we found on the defect at the aircraft, like the dimension, the stringer line, and so on. So we file the report and send to. Okay, so we file the report and the LAE send the report to CMO manufacturer, yes, to acquire the authorization of the report so that they can release the task card for LAE. So the damage can be done. So, okay, so next is this is our report. So go on.
Okay, so yeah, this one is the letter that we send to the manufacturer lah. So okay, next. Okay, so after that is cut out area and load loss calculation. So the cut out area is this. Yeah, the hidden damage. The hidden damage line is the damage that we occurred. So then, yeah, this is the damage area lah that we cut out from the skin. So then after that, okay, so this is the area that we remove. Specific area, which is area 1 is 1.05, and yeah, okay, that's the area. Okay, next. And the load loss that we found on our skin is we searched on tension and shear. So yeah, the resultant force is 5.025 times 10 power 4 Newton. And yeah, the other one is 2.680 times 10 power 4 Newton. So yeah, alright.
Oops, sorry.
Hello. Okay, since we have found the load loss, we will now fabricate the doubler. Next. Okay, first of all, we need to determine the doubler area. The same way how we determine the load loss. First, we need to find the area in the section A1 and A2. And then the horizontal section, which is the left side and the right side, which is area 3 and area 4. Those are the values. And then after we determine the area, we need to find the doubler strength. So the formula to find the doubler strength is very simple, which is stress times area. So the stress is the FTU value and the FTY value from the SIM table. And then we determine which to be used. So to use the FTU and FT why? We need to determine the lowest number, so we need to be conservative. And then those are the doubler strength that we found initially. It is lower than the load loss, so then we need to, next slide, we need to determine the margin of safety. So the margin of safety is simply the expression of the reserve factor minus 1. So reserve factor is the doubler strength over load loss and then minus 1. Which should be greater than 0. So to find the margin of safety, we need to divide the doubler strength, which we found just now, with load loss that we also found just now, and then minus 1, and then we got 0.143, which is more than enough. Next slide. For the factor of safety, okay, now since the original doubler that we calculate is not enough to achieve the factor of safety of 1.5, we calculate another calculation with different doubler. So first of all, we use the doubler with the material of aluminium alloy with thickness 1.6, which is the next height gauge. It doesn't achieve the 1.5. It is also true for aluminium alloy with thickness 1.8. Therefore, we use the doubler of different material, which is the stainless steel. First of all, we use the thickness of 1.6. It did achieve the factor of safety, but it is too high. Therefore, we use the thickness of the stainless steel that is the same as the doubler. With the same with the skin, which is 1.4. And then it did achieve the factor of safety of 1.9. Okay, next. Okay, so why we did this? Okay, yes, aluminium alloy can achieve the factor of safety above 1.5. However, it will be too thick. Therefore, it may cause problem in the future during operation. Therefore, we use the stainless steel. And as I have discussed just now, the reason why we use stainless steel with thickness of 1.4 is because 1.6 has factor of safety that is higher, too much higher. Okay, and then since we are using doubler material that is different than the skin, it may cause some dissimilar metal reaction. Therefore, we use cadmium plating. Okay, next. So the selection of the rivet from the SMRM table. So the rivet standard time is the MS20470. The material is 2024T3, which is aluminum alloy. The diameter is 4.8. The strength is 5220 Newton. Next. So, determination of the rivet number and positioning. So, to determine the number of rivet required, we need to divide the load loss over the strength of the individual rivet. And then, from the calculation, for area 1 and area 2, we found that we need to use at least 10. For area 3 and area 4, we need to at least use 6. Next. Giant analysis.
Macam ni?
Okay. Assalamualaikum and good evening everyone. This is type of failure that usually happen. For skill repairing, we only focus for the first, second and the third one. Analysis check. This is our repairing process, and the force that we use is 5,222 Newton. Force for tension check. The final answer is 73 megapascal and the margin safety is 4.5. For shear out, we get 194 megapascal and margin safety is 0.3. Next is bearing. We get 576 megapascal and margin safety is 0.5.
Okay, so for airworthiness compliances, so I won't talk much about this. So I'll just summarize it. So for the airworthiness compliances for subpart C, we basically are compliance with load. Sorry, I cannot recall everything. We comply with loads, factor of safety, strength and deformation, and also proof of structure are being complied accordingly to the airworthiness compliance sub C. For sub D, we also it consists of material, fabrication method, fastener, protection of structure, and also bearing factors are also complied accordingly. For subpart G, we come in consider is the maximum operating limitation speed of the aircraft. This is because our repair is comply with it because our repair capable to withstand more than normal scale due to additional strength on the doubler. Thank you.
Okay, so we take the value from bearing stress to identify the life cycle estimation because bearing stress has the largest value of stress with the value of 576 megapascal. So after plotting, we get 4,000 fatigue life cycle. So the fatigue life cycle is 4,000 cycles. For stress summary, all of this value is we get from previous calculation. So since all the margin stress is above the zero, then we can remark as margin safety as satisfied.
Right, so after you have all the numbers, all the details, next you do the actual procedure, and here will be it. First thing you do is you inspect. You inspect the area, the damaged area for cracks or anything. You can use magnifying glass, special instrument, and then if there is a crack, you further check it using NDT. Next. So after that, once you know there is a crack, you need to remove the damage. How you remove the damage? You cut it off, and then you clean all the edges, make sure there are no burrs, no sharp edges. Next. After that, if the damage requires a filler material, then you fabricate the fiberglass filler material, and then you fabricate the doubler. You get the dimensions just now calculated, then you cut it out, and you're ready. Next. After that, you install it. So you put the doubler there, drill all the holes, install the rivets, and you check. After you're done, you check it one last time, make sure everything is all correct, and you're done. Thank you.
When
Thank you, very good, really very good.
Hah? Ni. Tak ni. Ni. Tak apa.
Boleh. Okey. Group 13. Assalamualaikum warahmatullahi wabarakatuh and very good evening. So my name is Ahmad Isyad bin Yusuf and we are from group 13. So first thing first, I will introduce my group member. This is Amir Ashraf and this is Alice Izilda. This one is Omar Kia and the other one is Tina. Okay, so introduction. Okay, our aircraft is a Boeing 737, which is the operator is Southwest Airline, and the flight origin is from Nashville International Airport, and the destination is to Baltimore Washington International Airport. So as you can see, our aircraft can fit up to 131 occupants and 126 passengers. Next. Okay, so our aircraft has a damage, which is the damage type is material fatigue. It is caused due to repeated flight cycles and frequent use. So next. Okay, as you can see, this is our damage sketch. The damage is between stringer 1 and 2, and then the length is 70 inches and the height is 8 inches. So after that, we wrote a report to the service manual, which is the aircraft defect. Next. Okay, and then this is the letter of OEM. So the importance of letter of OEM is it means communication between the repair facility and the manufacturer of the aircraft. So that's all for me.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Airworthiness bin Sudani. So this is a repair design analysis, which is repair sketch for the damage.
Okay, as you can see, shear force will be acting on the front, because when the aircraft is moved forward, they will have a force that move backward and make a shear. So the tension will act at the top. So next. Okay, first of all, this is a calculation of the cross section area. You have to divide to the two areas. First is length time thickness, and the second one is width time thickness. So after that, make a conclusion of the load loss due to the damage. You need to find the force tension and force shear and force resultant on the both area, which is area 1 and area 2. Next is a double strength. First, calculation of the double strength on the original and doubler. Original first section length time thickness, and then you need to find the tension max and shear max on the original and doubler area.
And next is calculation of the margin safety, which is margin safety equal to reserve factor minus 1, and the reserve factor you need to allowable load over applied load, and from that you can find the reserve factor. Okay, next. Okay, for factor of safety is 1.5. This is because based on the aircraft structural manual in aircraft design, the factor of safety is stated 1.5. Besides that, the factor of safety can be found using the formula, which is ultimate load equal to 1.5 times limit load. Therefore, the rivet that was selected in this repair is universal head rivet. So this is a calculation on how many numbers of rivet per row and number of row needed to carry the load loss. So there is 3 row. For single row, you need to find the force over the number of row, and then number of rivet per row. Divide the force for single row over the force that you can be found on the rivet table. Depends on the type of rivet that you choose to use. So from this we can see that it is approximately 12 rivet per row. So next, okay, this one is the calculation on the maximum stress. So 405 megapascal can be used to repair the fractured skin before it will become the plastic deformation. Okay. Next is stress check calculation. For the stress check calculation, you need to consider 4 things, which is net tension, shear out, bearing shear, bearing stress, and fastener shear. Okay, next, that's all from me, so I will pass to the next presenter.
Yeah, Assalamualaikum. Okay, so I will be presenting on life of repair. So this is the graph between the skin's maximum stress and its maximum fatigue life cycle before it will undergo plastic deformation. So based on the graph, our repair fatigue life cycle is maximum life is 400,000 cycles. Okay, next. And then we calculate the margin of safety to define how much it can withstand before it reaches its breaking point. And based on all the calculations, our new skin is able to withstand all the stress that will act upon it, because the margin of safety is more than 1. So I will pass to the next presenter. Oh, sorry.
Okay, Assalamualaikum. My name is Umar Asyar. So today I will be presenting on procedure to repair the damage. The first procedure is by inspection. There are 2 types of visual inspection. That is, first, carry out a detailed visual inspection by using a 10 power magnifying glass for a visual inspection, or the other one is conduct NDT if there is damage found. The next procedure is removing the damage. Cut off the damage and clean all the sharp edges. In this step, there will be a caution, that is, if the repair area is not on contoured surface, then do not remove the damage perpendicular to the surface. If you do not obey, the repair will not be satisfactory. I will pass to the next presenter. Inshallah.
Next is for the C procedure, which is fabric filler and fabricate doubler. So first we need to make sure that the cell wall of the repair core are installed parallel to the initial core of the cell walls, and the next maximum error permitted is 13 degrees. So for D is installation, drill hole size 4 mm and then install rivets, apply sealant on doubler and install doubler. So we need to use the adhesive substance to adhere the repair doubler and then wrap the repair with polyester tape to prevent the doubler from shifting during the cure last stage. Do not seal the edges of the panel. If you seal the edges of the panel, it can prevent the flow of the adhesive material and can disrupt the last step of the cure. Thank you.
Thank you. 13.
So, ni macam mana? Cabut je?
Sikit tutup.
Ha? Cabut je. Ni ada charger bla dah cancel. Ni tu situ. Editing apa kata nak video.
Mana yang dia pernah kali?
Okay, Assalamualaikum warahmatullahi wabarakatuh. We are from group 12. So my name is Muhammad Yassin. So today I will present about the incident that happened of Southwest Airlines flight 8112. That was Boeing 737-300. So the incident of the flight, it's happened because of the rapid depressurization while cruising at 34,000 feet. Tak nampak. Ni second ni. Dah ni dah sebut tadi. So we go on to the next slide. So the factors cause of the defect or damage is the crown skin panel and the upper left of the fuselage panel were misaligned. So most of the low rivet row holes were misdrilled. And fuselage skin damaged about 60 inches long by 8 inches wide, head fracture and flap open on upper left side above the fuselage. Next slide. So for the design and repair, for the length of the doubler, we use to expand the doubler of the rivet hole of the hole, which is 6 inches more than the hole and 6 inches in length. So we move on to the next presenter.
Hello, Assalamualaikum. My name is Kamal Farid from Group 12. So we present about design repair analysis. First of all, we have to find the load loss and double strength. If you want to find the load loss and double strength, we use the same method. We have to find the PTU, PSU. After you find this both value, we have to find the resultant force for every area that we design the doubler. Okay, for example, my group, we have A1, A3, A2, A3 2.61 kilonewton. If you can understand, I hope you understand. Okay, for margin safety, we use the formula of double strength over load loss. And we got our margin safety is bigger than 1 for both areas. And for the factor of safety, we use the same formula, but for factor safety, it needs to be bigger than 1.5. But for our design, double design, it didn't meet the requirement. So we got 1 point something that is below 1.5. Sorry, sir. Okay, for explanation, our design and dimension of our doubler doesn't meet the specification for factor of safety, which is 1.5. I analyzed the problem might be because of the thickness of our doubler doesn't meet requirement. That's why the factor of safety not safe. Okay. For the selected revert, we use MS20470 2040 table. From that table, we identify the diameter and the thickness of the revert, and we use the 4.8 diameter revert. Okay. For the number 6 question. What I do, for one area, I found how many rows of rivet can be in one area. After I found that 18 rows in one area. So each row of each row need to have 3 rivet by using that formula. That formula is number of fastener for each row. Okay. Okay, Dennis. Okay, after that, this is stress analysis. This stress analysis we conduct on the rivet. We have net tension, shear out, and bearing. Okay, this stress we only use formula F over area. The differences of these three is the area. As you can see, for the area net tension is length minus diameter times by thickness. While for shear up is 2D times T times 2. We have to understand and think for this formula, not just remember. Okay, understand. Faham Afiq? Okay. That's the value that we get. Okay. That's all from me, sir. Thank you, sir. Group 12, sir. Sorry, Afiq. Lebah.
Okay, Bismillahirrahmanirrahim. My name is Muhammad Ismail Badalan. So I will present about stress summary. As you can see, for each stress it must exceed margin of safety 1.5 and above to make it can withstand with the stress. So for our group, all of the stress is exceed 1.5. So the skin can withstand with the stress. Okay, next. So life of repair. The purpose of this table is to get the repair cycles of the doubler. So for our group, we got around 40,000 cycles for the repair. Okay, next. So last but not least, repair instruction. So for damage inspection, first we have to carry out a detailed visual inspection of the damage using appropriate tools. Then next is examine the damage closely to determine the extent, severity and any potential underlying issues. And then if the visual inspections reveals any concerns on or if the damage is in critical area, consider conducting NDT. Okay. Next is remove damage. First use appropriate cutting tools to carefully remove the damaged area, and then after removing the damaged area, carefully inspect the edges to identify any sharp or jagged areas. Okay. Next. Fabrication. Depending on the nature of the repair, prepare the filler material required to fill the void left by the removed damage. And if the repair requires a patch or replacement part, fabricate it using suitable materials. And then for installation, if necessary, drill a holes and then install the fastener at the drill holes. Apply an adhesive or bonding agent, and then align the repair patch with the damaged area, taking care to position it accurately. Securely attach the repair patch to the component by tightening the fastener. And then lastly, conduct conduct post-installation inspection to verify and qualify and effectiveness of the repair. That's all from our group, I think. Next. Okay, thank you. Cabut je.
Test. Okay, test. Okay, Assalamualaikum. Sir, we from group 14. We will start our presentation. Okay, my name is Umar bin Azizan. Okay, as for our group, our case study is Southwest Airline Flight 812. As for the aircraft type is Boeing 737-300. Next. Okay, as for the first part, which is what are the costs for this incident? Okay, this aircraft, this flight experienced fast depressurization at 34,000 feet, and the fuselage skin fractured and flap open. As these two figures shows for global view and the local view. Next. Okay, as for the second chapter, report of damage, it consists of 3 parts. As the first one, aircraft defect, and then component data, and the next one is the letter of OEM. Okay, next. Okay, for chapter 3, cut for repair. As you guys can see from the sketch, for the first area is the length times by thickness, as the second area is the width times thickness. After we got the measurement, and then we calculate for tension, shear and resultant for both areas. As for the next part, I will pass to my teammate. Bagi tahu nama.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Dilaiman bin Mazlan, and I will explain about the calculation. This is roughly the calculation, and first of all we must calculate the load loss and the double strength, which is the formula of double strength is stress times area. After that, we go to the calculation of margin of safety and factor of safety. The margin of safety is much bigger than 1, while the factor of safety must bigger 1.5. Next, next is the stress analysis, which is net tension, shear out and bearing stress. All the formula is force over area, but the area is different. The area is different. Sekejap je.
We are going to chapter 7, which is the chart is showed as represent the life of the aircraft.
Cepat
is the stress that you can get. It means that the fatigue line will be even increased when the stress is higher. So for the next slide, I will pass to you.
Okay, for next part is chapter 8, stress summary.
as we know that budget safety is much more than one. Okay. Okay, for the share out, more than one, there is 1.5. The tension 43.5, and the bearing is 0.73. For bearing not able to withstand the bearing. For the share out and net tension can able to withstand the stress. Alright, next. Alright, my name is Mohammed Fazli. Now I will go to procedure of preparing the damage. So carry out the detailed visual inspection and conduct NDT if damage is found. So visual inspection focus on critical areas. Required take the screen off. So then conduct active testing of NDT or else perform an ND current inspection of the penetrant inspection. Then remove damage of the damage on the sharp edge. Remove the ending of sharp edge. Patient do not remove the damage perpendicular to the surface if the repair area is on the corner surface. The repair will not be satisfactory if do not complete. Then fabricate repair material, fabric filler and level. For fabric filler, apply the resin, allow the bridal filler, allow the current for drying. Then for the rubber, applying the resin, position the rubber, allow the current for drying. So also make sure that the ribbon section of the core align in the same direction as the ribbon direction of the core to be repaired. Installation. 3 cold size for mm install ribbon, apply the cement or install the number. Perform a panel inspection. Once the installation is complete and the cement and ribbon is correct, inspect the repair area to ensure the panel is secure, attached, and the required standard and specification. Question: do not seal the edge of the panel. If the seal edge of the panel, it can prevent the flow of the advanced material and removal of the air during the final stage of the job. Thank you.
Okay, so that's all from our group. Thank you. Tak payah.
Oh, nice. Kau kan nak last. Dah. Ya, bisa. Hoi. Ya. Itu 456. Ya. Sabar. Mana ni? Duduk sama mana? Wadah. Pegang. Tes. Alright, assalamualaikum to all my friends. Good and very good evening to my lecturer and all my friends. So we from group 5. So we will proceed direct to chapter number 1. So the second one is regarding about the airline that we chose. There is Aloha Airlines flight 243. That is the accident is been in 1988. Next slide. So basically this is the diagram. So basically the accident take on the station around the zone around 360 until 50, which is the upper fuselage will be detached due to the corrosion and fatigue. And the crack is between the larger crack is between 0.08 inch, but the downwards crack is around 0.04 inch. Next. Okay, so chapter number 2 is regarding about the OU emulator. So basically we will fill up regarding the report. Cakap briefly lah. We report about the airport and the damage and also the zone of the aircraft. Next. Next. So for chapter 3, this is the diagram about the layout around about the damage. So basically chapter 3 we will calculate the tensile stress and also the pure stress. So we will get about all the load loss. So basically next. Cepat saya tu. Aku tak sempat cakap apa pun.
Okay, my name is Muhammad Safadi. So the assignment 4 is calculate the load loss. We got two area, area 1 and area 2. The area 1 we got 1.9845 kn and the area 2 is 2.0324. And the next one is calculate the double strength, cut out the original part. And we got two sections, section 1 and section 2. And the final is 2.56 kilonewton. Next. And then the calculate margin of the safety is 1.91 kn, and the calculate factor of safety we got 1.5. Explain the result. Next. Chapter 5 is stress checks and tensile stress. The stress or the force that stretch or pull material apart is mechanical stress that happen when opposing force at both end of the object. Tensile stress can be calculated as the ratio of the applied force per unit stress force times area. Next. Okay. To conclude the chapter 6 is airworthiness compliance. Refer to the set of regulatory requirements the aircraft must meet to be deemed safe to operate in the national airspace. These requirements are designed to ensure that aircraft are construct, maintain and operate in a manner that minimize the risk of accident and maintain the highest level of safety. Okay. Next.
Okay, my name is Richard Mensai, so I will cover the Zoom. So the claim is mixed stress management, and the result we could is around 400 megapascal. Okay. So for the stress summary, the result that we get is all exits from 1. Show up is from the capacity of 1.9. Then tension is 150, 1.9. And the bearing is 150, 2.0. Okay. So for the procedure of military damage, there is 4 procedures. For the first procedure is inspection. So inspection, basically we determine the extent of the damage, eliminate the area, and use the technique to identify any hidden damage or not. For second procedure is remove damage. Basically we remove the damage component from the to ensure the surrounding area unharmed. For third step is fabricate repair material. So basically this may involve manufacturing investment parts or construction to repair patch using appropriate material, and the last step is installation. So we prepare component manufactured and product on the aircraft and secure using a personnel. So basically the personnel we install with specific top rating. So I think that's all.
Belum masuk lagi, kau tak bertanya lagi. Duplicate stand. Duplicate stand.
Hello? Hello? Eh?
Buka.
Hello? Hello?
Kurang tekan dah.
Duplicate kan?
Tengok kabel. Ni HDMI.
HDMI. Tu pergi ke asal.
Boleh ke? Dapat boleh je. Boleh direct? Kau punya ni ada ni?
Tak ada. Hai. Apa dulu? Macam tu kan?
Tengok.
So, kena connect, sir?
Baik, kau tak tu bila selesai. Baik, dia takut ni.
Tu? Boleh. Baik tu. Okay. Dua-dua. Assalamualaikum warahmatullahi wabarakatuh. So greetings to my fellow friends and thanks to Prof. Abu Hanifah for the opportunity. So basically we are from group 2. So I would like to introduce myself. My name is Muhammad Firdaus and this is my colleague Hassan, Ishaduddin and Farihin. Next slide. Next slide. So for the introduction, so basically I want to emphasize that this assignment is not according to real life incident. However, there is a scenario given. The aircraft hit the cargo loader that has damaged the stringer and the skin on the fuselage. So I will hand out this microphone to my next colleague.
Okay, continue. So we continue with the description of damage of this aircraft. That is so. Okay. So basically this is the global view of the aircraft. So as you cannot see right now, but I will describe it. So the position of the damage will be inner side of the fuselage. That is in between the. Okay, next. in between the body section 600 to 700. So okay, this is the local view for the stringer. And one more thing, I will one more thing for this problem, for this aircraft, it will have two damage that will be on the stringer, and one more will be on the skin of the aircraft. Okay, next. So basically the design repair, okay, because of we have two damage that will be on the stringer. So the first basically the design repair, as you cannot, maybe you cannot see, but I will describe it to you. So basically for the stringer, it has a crack in the middle of the stringer, so we are making a more type of Z shape of doubler to cover the in the part that we already cut. And for the skin, so basically we make a square shape because we will cut a square size of the hole, and then we make a double that have a bigger size of square, and then that's all, I think. Next please. Next those. Okay, Chad, I will pass it to you, Chad.
Okay, so for the calculation, so first and foremost, we need to calculate the loss. So for the loss, which is 1.5 times 51, and times with the area. So we can get the value, which is 8,162 meters. For double strike, we have the same formula as the loss, but the difference in thickness. The thickness of double strike will be 1 inch higher than the loss. So then that's the logic of safety. So margin of safety is the double strike divided by the loss. So we get next slide.
Next slide, house. Dah biar. Okay.
Okay, so safety we get 0.9, which is near to 1. For factor of safety, same formula, and we got only 1. So we need to be concerned that this repair is not not comply with the factor of safety and margin of safety.
Next.
So for the selection of rivet, we can find first the diameter of the rivet using the thickness of the cylinder. So we have the thickness of cylinder, which is 2.2, and we have the rivet diameter, which is 5.6 mm. So after the calculation, we have the rivet shear, force shear is 364 meters. So we times it with 3, with 4, and we can get 80,300 meters. So that's that. So for the second rivet, please.
Terbuang ke? Next set.
So for the stress analysis.
Next.
So for the stress analysis, we measure the net tension, the stress, and shear stress. So for the formula, as usual, we have the area, we calculate the area, and then for net tension, we have the force over area. So we get the force, which is for single unit, which is 364 meters. So we set that and we calculate the area. So we get 8.6 megawatt. So for the shear out, we use the formula for the area, which is 4 dt. So we use the force from level which is FSU, and we get 3,600 divided by the area calculated. So then we calculate the very size. We use the formula for the area which is diameter times the thickness, and we have force for very times the area, so we can get the very size.
Tengok
So next slide.
Tak, ini data tadi.
So these are the data for data money. So here we can see that it is
Sebab apa kalau tunjuk pun kau nampak. Faham? Tadi saya dekat semua data tadi. Ini semua data tadi.
Banyak
aku. Ya kau lah. Nah, dah Hasan.
So we pass to Hasan.
Assalamualaikum warahmatullahi wabarakatuh. Okay, for life of repair, you know that our maximum stress is 405 megapascal. So from the graph we drop the line and drop to the fatty life, and we get the average around 10,000 until 100 cycle of fatty life. So we got 20,000 cycle for fatty life. Next is about repair, structure repair. Okay, there are 4 steps for structure repair. First is inspection, second is remove damage, third is fabricate repair material and installations. Next, for inspections, there are two ways. First is we carry out detailed visual inspections. Second is if damage found, we conduct ADT. Basically, for structure we conduct AD currents. So for our damage, we conduct AD current. For the singer. Next is remove damage. There are two. First is we cut off the damage, which is by using grinder or others. Second is we clean all sharp edge with files or sandpapers. Next is fabricate repair material, which is filler or doubler. Next. Lastly is we install the doubler. Firstly, we drill hole. And second, we install the repair, and lastly, we apply sealant, and lastly, we apply the doubler. That's all. Thank you. Which one, sir? Which one, sir? Oh. Yeah. Alright, sir.
Selling or marketing presentation. That repair structure is exactly how to repair that area.
Okay, sir.
But the detail visual instruction is history and the defect we have shown earlier.
Alright, sir.
Okay.
Alright, sir.
Don't do that in future.
Okay, sir.
Meeting. We just start jump up to the halal.
Nah.
Okay, next.
Cakap kaku.
Sebelum dia di pertahanan. Aku nak makan dia, nak makan dia. Faham? Tapi boleh je nak makan dia tu. Sedap.
Apa?
Bagi asal balik lah.
Ayo ada aku
Okay, Assalamualaikum warahmatullahi wabarakatuh. So we from group 15. So my name is Muhammad Amirul bin Sauki, and 2% only, sir. Okay. So 15. So this is the chapter 1. So Boeing 737 global view and defect. So you can see the diagram here. So post accident inspection of the airplane reveal the section of fuselage. So next slide. Fuselage. Sorry. So this is the report of the mesh. So next. This one is the component data. So detail of finding defect or damage, and the last one is the letter to the Boeing aircraft company.
This is the assignment 3.
Sabar. Next. So for the question, for the A1, P tension we got 65.84, P shear we got 41.45. For the resultant we got 77.8. For the A2 we got the tension 493.78, and for the shear 310.896, and for the resultant 583.5. So this is the plastic deformation. 405 MPa can be used to repair the fractured skin. So on the chapter 4, we are going to calculate the load loss, calculate the double strength, margin of safety, factor of safety, and explain the result on calculate. So this is the area that we find. So this one is the load loss. We got resultant for A1, A3 258.44, and the other one 1206.05 kilonewton. So this one is the double strength calculation. So the formula we use are stress times the area. So we got the tension is 230.688, and the shear 145.248, and the resultant is 272.61. So this is the margin of safety. So the formula is double strength over the load loss. So the margin of safety is much higher than 1. So we got here 1.064, and then the factor of safety much higher than 1.5. So we got for the area 1 and 3 is 1.055, and for area 2 and 4 1.064. So this is the calculation of the number of row. So we got 19 row for the A1 and A3, and 88 row for A2 and A4. So this is the calculation of fastener. So number of fastener we got, each row is 3 fastener, and the other row is 3 also. So this is assignment 5. The first one, we need to find the net tension. We use the formula force over area. We got 9.3 MPa.
The second one is we need to find shear out. We use force over area, and we got 169.92. And for bearing, we use formula force over bearing area, and we got 679.7 MPa. And the last one, fastener shear, we use load over cross section area of rivet, and we got 288.47 MPa. Next. So for the subpart C, we use factor of safety, loads, proof of structure. For the subpart D, we use protection of structure, fastener, and fabrication method. And the last one, subpart G, we use operating limitation. So for margin of safety for shear out is 1.5 and able to withstand the shear out. The net tension is 43.5. The bearing 0.74. For the fastener 0.884.
So for the last chapter, so to repair the damage, so the first of all we can do the inspection. So we carry out a detailed visual inspection of the damage. So this includes looking for crack, then hole and other sign of damage. So we pay attention to condition of the surrounding structure as well. So the next one, we can remove damage. So once the extent of the damage has been assessed, you can begin to remove the damage, either cutting, grinding or drilling. So next one is fabricate, repair material. So once the damaged area has been removed, you need to fabricate to repair the material, and then we do installation. So once the repair material has been fabricated, you can install them. Post repair inspection. So once the repairs be installed, you need to inspect it carefully. And the last one is documentation. So you need to document the repair process. This includes a description of the damage, the repair material used, and the inspection result. So by following this procedure, you can ensure that the damage to your aircraft is repaired safely and effectively.
Thank you.
So thank you. Okay, that's all from us. Thank you.
Okey, dah mal. Tepi sikit, nak mic keluar. Buat full presentation. Tak, pergilah slide first tu. Okay, Assalamualaikum warahmatullahi wabarakatuh. So we are from group 11 and we'll be presenting in 4 person. First is me, Khairul Muaz, and my group members are Aiman Akif, Amir Iqbal and also Naim Ash'an. So our group will be presenting for the Southwest Airline Flight 812, which and it have a fuselage skin structural collapse, which is caused by a 60-inch hole and on the upper fuselage. So another one. Okay, so this is the design of the repair. The hole itself was between stringer 4L and 5L. and between body section 663 and body section 725. So next is the repair design analysis. So here we can see the conversion from inch to mm for each of the measurement. We have 4 of it. So next, okay,
so we're moving on. So for the right picture, as you can see, is regarding the cutout original parts. So there's a calculation here. For the section, we have 480 millimeter squared. For the tension is 194 kilonewton, and for the shear max is 122 kilonewtons. So we got the calculation is 229.72 kilonewtons. So to repair the original parts, we need to have the calculation for the double repair. So for the double repair, we have 990 millimeter squared. For tension is 388.8 kilonewton. For shear max is 244.8 kilonewton, and we got the resultant for is 459.45 kilonewtons. Alright, moving on. So we continue on for the reserve factor. So there's for tensile reserve factor and also for shear reserve factor. So both of the result for margin of safety is more than 2. Okay, next. Alright, we continue on. For the minimum, we got 405 megapascal, and for both ultimates, the original part we have 3270 newton, and for the double repair we got 3660 newton. So because one row has 3 fasteners, so we multiply by 3 for the original parts, so we got 9810. And we need to divide it for the original with the original parts. So we got 23.4. So we need to round it. So we got for 24 rows, which we need 72 fasteners. And continue. So next is for the stress analysis. As you can see, sir, for the net tension we have 15.2 megapascal. For the shear out is 22 megapascal, and lastly for the bearing stress is 90 megapascal. Alright, for the summary for the calculation, for the shear out, it is acceptable for the net tension, and also bearing is also acceptable to be repaired. Continue. Alright, lastly, this is only an estimation for life of repair, as you can see from the graph. Next. Alright, I give to Iqbal next.
Okay, Assalamualaikum. My name is Iqbal. For the repair instruction, as you can see, the basic principle of sheet metal repair is the primary objective is to restore the damage. And next, the inspection is very crucial, because from the inspection we can determine the repair. So here is the procedure for the inspection. Firstly, you need to remove all the grease and the paint from the damage and the damage surrounding area. And next, you need to inspect the skin breaker throughout the area, and then you can check the operation of all the movable parts. You can hold and touch the parts that are damaged, so that you can determine what repair you can best to proceed. So to determine the repair, you have a few things to consider. Firstly is you need to consider the aircraft need to maintain their original strength. Second, the aircraft need to maintain the original contour or the original outline of the aircraft. And lastly, the repair need to minimize its weight. Okay, next. So, clarification of the damage. First, the negligible damage. The negligible damage is damage that consider visual apparent surface damage that do not affect the structure, as small defect like dent, small dent. Next, damage repairable by patching. Any damage that exceeds negligible damage, like it's excessive dent or excessive scratch, you need to make a patching. The third one is damage repairable by insertion. Damage must be repaired by insertion when the area is too large to be patched. Like the first picture, that is in the first picture, the scratch is too large to be patched. Okay, next. Okay, I pass to Naik.
Assalamualaikum. So for the procedure there are three main part. So the first we inspect the damage, and the second one is we determine whether we need to replace the damaged part or not. So in our case, we need to replace that part. After that, we continue with the installation. So there's one point that I want to highlight. So when we fabricated the double filler use same material and thickness. So for aluminium, we need to use corrosion protection. So that's all from us. Thank you.
Alright, thank you. Excellent. So see you
Next week. Nadira.
See you live. So for the final, just what you do from chapter 1 till the end, those are the final.
Alright.
Thank you, sir.
Thank you, sir.
Lock loss, double strength, double fastener,
Sir, soalan final dia mostly yang assignment ya. Yang ni lah.
Mic jangan ni.
Mic. Mana?
Please.
Oh.
Jangan bawa balik.
Oh, sorry sir.